Short video on how to identify energy changes in nuclear reactions, in particular when working through the worksheets and for the ILLs. So you're going to have to recall from watching the previous videos on nuclear physics. We went over this slide where I explained how to identify the energy tanks. Each energy tank is an energy system, whether the energy tank or the energy of that tank or the energy system, whether its energy is increasing or decreasing. So I explained in that video how to identify that. So go back and review that to make so you can identify that in your nuclear reaction equations. And as always, whether it's atomic bonds or nuclear bonds, when a bond is made, think about it, something is falling or bonded or snapped together or falling into a well, bound in the well, energy gets released. And so we must put in energy to break a bond. And that is quite similar when we talked about atomic bonds in the very beginning. When running water through its phases from a solid to a gas. We have to put energy in to the water to vaporize it, which is microscopically from the bond picture breaking bonds, or when the water is sublimating and the bonds are being formed from gas to a solid state, energy is being released like a heat pack. And then in that same video, we'll go back to it, identify how to identify whether the electrical energy, PE electric, or the electrical energy is going to increase or decrease. What changes in the nucleus tell you whether it's an increase or decrease. And for the thermal energy, that's energy going into the environment. So we can call it environmental, the energy of the environment, or the thermal energy. And that you identify by the direction on this Nike swoosh graph, the Nike swoosh graph here of energy per the nucleon, or the mass per the nucleon. And so again, if you're going towards iron, you're releasing energy, and if you're going away from, if your nuclear reaction is heading in the direction away from iron, at the overall reaction, then energy is going in. So releasing energy means it's going to the environment, and whether it's endofission or endofusion, means it's going into the system from the environment. Okay, so you can tell whether the environmental energy is going up or down by the direction in this Nike swoosh, whether it's endo or exo. And that was the concerning the slides of fusion, and the slides of fission work the same way. So again, recall from a different video, go back to that if you need to. I reviewed when these energy tanks, when those systems increase or decrease energy. And how do you know? So go back and understand that, review that. And then lastly, the change in mass. Well, by Einstein's equation, if the mass is increasing or decreasing, that corresponds to energies increasing or decreasing. So again, going back to this Nike swoosh, if the energy per nucleon, or the mass per nucleon, we can tell if that's changing by, again, the direction you're heading. If you're going down this energy curve, or you think about it as down the mass curve towards iron, then your energy is being released to the environment, and therefore energy is being released from the system. The mass of the system, the mass of the nucleus, is decreasing. If the mass of the nucleus increases, it's because energy overall went into the nucleus. So endo or exo correspond to increases or decreases respectively of the mass. And then lastly, recall again from your viewings of the videos, this slide here where we identify in what types of nuclear reactions are occurring. How do you identify whether it's alpha, beta decays, or it's a nuclear reaction that involves gamma rays, and what the neutrino is. So make sure you go back and review those in the lecture videos so they can best go through the worksheets. And the four forces, or the four energies, the fourth one being the weak force. The weak force, as explained, and as seen in this slide right here, relates to the changes in the nucleons. And what changes can happen in the nucleons besides its energy and its mass? Well, the nucleon can change its state from being a proton to a neutron. It changes its characteristic. And so again, if a nucleon is at the weak interaction, or the weak force, or the weak energy, concerns the nucleon changing from a proton to a neutron, or neutron to a proton, and the rest that goes with that. And so again, by Einstein's equation, if your nucleon is changing its mass, then it must be changing its energy. And what energy is that? That's the weak energy. So to be clear, if your nucleon is decreasing its mass, it must be decreasing in weak energy. And if it's increasing in its weak energy, it corresponds to an increase in mass. So looking at the reactions that involve neutron to proton and proton to neutron changes, just think about which direction the mass is. Are you increasing or decreasing your mass as the nucleon is changing? And that tells you whether the weak energy is increasing or decreasing correspondingly. And the indicator for a weak interaction, or therefore a change in the nucleon, is a neutrino is involved. Whether it's a neutrino matter or an antimatter, an antineutrino, that's an indicator that there's a weak interaction involved, meaning that there was a change in the nucleon from proton to neutron or neutron to proton. So review all that, and may the four forces be with you.